I did.
Okay. The problem that I've picked for today's notes is one that I would consider more challenging, one that you probably won't see on a quiz or a test. But it gives us an opportunity to have some really good conversations about like rethinking our ideas, thinking ahead, and looking for other routes to take if we're not happy with what we see. Okay. So notice that in my example that I have on the board, if I look at the left and right side, to be real honest, neither one is really very nice. Like it's not simplified to just cosine. What am I using? Theta. So you could really take your pick, and remember we talked about when we were going over homework, you can actually work on both sides. So that might be something that we decide to do. But if I had to choose one that was more complicated than the other, I guess maybe I would choose the left side just because it has more stuff. So I'm going to ask you to look at the left side, sine theta, tangent squared theta over secant theta minus 1, and kind of look back at your identities. And let's just throw out some ideas for things we could do. We're not actually going to always do what people suggest. We're going to think ahead and see, is that really going to get us somewhere we want to go? So what's some idea of something I can do on the left side? Tangent could be changed into a reciprocal. So you mean 1 over cotangent? Okay. Think ahead.
Well, I would say like sine.
Oh, sine squared over cosine squared, that's not reciprocal, that is the quotient identity. Okay, so if you did a substitution of sine squared over cosine squared right there for tangent, I'm not going to write it down. Think ahead to what would happen next. Sine squared over cosine squared, and then it would be times sine. So now in the numerator we have sine cubed over cosine squared. Not that we couldn't do that, but if you're just thinking about that, have we really ever seen that before? No, so I'm wondering, is that my best option? Because it has nothing to do with the secant theta minus 1 in the denominator. So before I commit to a quotient identity right there, I'm going to see if there's anything else I can do.
You can do secant theta minus 1 is the same as tangent squared, right? No, it's secant squared.
Oh, yeah. Okay, so I have two things here. We're going to go back to Jayla's quotient. And Hannah, what is that thing that you were looking at?
That's the Pythagorean.
Pythagorean identity. And we have a Pythagorean identity in our notes. Does it say 1 plus tangent squared theta equals secant squared theta? Okay. So there's two pieces here, and they're at play. Remember, Jayla saw the tangent, and she wanted to do quotient. She wanted to change it to sine squared over cosine squared. We use that a lot. And I said, well, think ahead. That's going to create sine cubed over cosine squared. We really don't know what we would do with that. But I like that she was looking at tangent, because if you look over there on that left side, sine and secant are both part of the sine and cosine families. So if we'd used the quotient, we would have turned everything into sines and cosines. So tangent is probably the thing we want to change. Now, one way to change that is the quotient. Hannah was looking at the denominator, and she saw secant theta minus 1, which this is very common to think about Pythagorean identities. But in order to use the Pythagorean identity, it has to be secant squared. So we can rearrange this one here. Tangent squared theta equals secant squared theta minus 1. We can't use that Pythagorean identity in the denominator, but we can use it in the numerator. So if you're thinking about, would I use quotient identity or Pythagorean identity for tangent squared in the numerator, we're going to choose Pythagorean identity because it looks more like the denominator. Okay, so let's make that substitution. Oh, got a substitute. This is times secant squared theta minus 1 all over secant theta minus 1 equals cosine theta plus 1 over cotangent. Pythagorean identity. remember, I picked a harder problem. And this is a great one to model that idea of like thinking ahead and like what's that going to look like in my problem. This probably looks nicer right now than if we'd used the quotient identity. So we're making choices to try to work more efficiently. Work smarter, not harder. All right. Any ideas for what we might try next, Hannah?
You can factor the top, so it's secant theta minus 1, secant theta plus 1.
Excellent.
Oh my gosh.
Factor the secant squared theta minus 1. That's a difference of perfect squares. Okay. If you had the urge to cancel secants, just beware of getting cancel happy. Why can we not cancel those secants right now? They have a plus or minus. They're not factors, they're terms in a factor. So like secant squared theta minus 1 currently is a factor in the numerator, and secant theta minus 1 is a factor in the denominator. So I have to have exactly the same thing in the top and the bottom to cancel. And right now I can't cancel. But if I factor the difference of perfect squares, then yeah, I'm going to be able to cancel. So let's do that. I'll move this up here in just a second. Sine theta times secant theta plus 1 times secant theta minus 1 all over secant theta minus 1 equals cosine theta plus 1. I will put a little special shout out there to factoring. It's something that often is overlooked by students, and it simplifies your work a lot. And so I would make sure you put factoring at the top of your list of things to check for quizzes and tests. You know, if you're starting a problem, check to see if anything factors out. Okay, so that's awesome because when I factor, I can cancel the secant theta minus 1. You can say cancel, divide, I don't know, whatever you say. We're not real picky about those words anyway. Okay, now I'm going to let you guys kind of look at it and decide what you want to try next.
Go to the other side.
Oh, some people want to go to the other side. Yeah, you might say like the left side's looking pretty good. Now let me move over to the other side. What do you want to do to the other side? Well, one thing you might not like about the other side is that it has a division, right? It has a fraction with the denominator. So if you have cotangent in the denominator, that turns into tangent in the numerator. So I'm going to use my reciprocal identity for that and flip the cotangent up to the numerator, making it a tangent. Then it looks a little bit more like the other side. So that's my reciprocal identity. They look similar, but they each have different trig ratios. So we might have to get a little creative there. Any ideas? Get them all into sines and cosines. Now's not a bad time to do that, right? So should we just use a mix of quotient and reciprocal identities? Okay, let's just change everything. This is the sine theta times 1 over cosine theta plus 1 equals sine theta over cosine theta times cosine theta plus 1. So I used a reciprocal and a quotient identity for that. But I had a reason to do that, right? Get everything in sines and cosines. else can I do? Distribute. Awesome, I didn't hear you. You must have been whispering it and then Liam heard it. Yeah, we could distribute. We can distribute on both sides, right? Okay, so I'm going to distribute on both sides. That gets me sine theta over cosine theta plus sine theta equals sine theta plus sine theta over cosine theta. I did it. They're the same.
Oh, yeah.
Addition is commutative. 3 plus 5 is 5 plus 3. So it doesn't matter that they're in the opposite orders. You could, if you wanted to keep going, both sides simplify to be tangent plus sine, right? But at this point, if you have the two sides equal, you don't have to continue simplifying. Like you've proven two sides equal, so you can be done. Okay, not bad. You made some good choices there. I like it. Okay, what I want you to do with the rest of the period is work on the next homework assignment, or if you need to go back to the page 355 or page 362 and do any of those problems, you can. There's 5 problems tonight. Tomorrow we're going to be doing review activity of looking at work that's already done and finding the error. And then you'll have review assignment, extra problems to practice before the quiz. Friday at the beginning of class, you'll take a quiz, and we'll end the last half of class. We'll just introduce solving equations with trig functions in them.
Are you sure we're